When the Soviet Union's Venera program successfully transmitted unprecedented data from the surface of Venus, it was not just a victory in planetary exploration. It sent seismic shockwaves through the global scientific community, especially in the United States. The discovery was truly astonishing. American scientists, although aware of the USSR's progress in the study of Venus, did not expect the scale and depth of the Soviet findings. This was not just dry data from a distant planet. It was exceptional confirmation that the second planet from the Sun was far stranger and more hostile than anyone had imagined. The mission that delivered this blow was Venera 13, launched in 1981 and landed in 1982. Although previous Soviet missions made Venus the first planet after Earth to be visited by an artificial spacecraft, it was Venera 13 that truly lifted the veil of mystery. The spacecraft operated on the harsh surface of Venus for more than 2 hours, longer than anyone dared to hope, and transmitted not only telemetry and temperature data, but also color photographs, chemical analysis of the soil, and acoustic recordings of the Venusian wind. These were not just curious details. They were keys to understanding a planetary system that obeyed rules completely alien to Earth. The shock began with the atmospheric readings. The pressure at the landing site was about 90 atmospheres, equivalent to the pressure at a depth of almost a kilometer underwater on Earth. The surface temperature remained around 465 degrees Celsius, enough to melt lead. And yet, the Soviet probe withstood these conditions, which American engineers considered almost insurmountable. The very fact that the USSR was able to develop a device capable of operating in such extreme conditions was a technical achievement that forced NASA to reconsider not only its ideas about Venus, but also about Soviet capabilities in deep space. But it was the images and chemical data that caused the real shock. For the first time in human history, we saw the surface of Venus not as an abstraction drawn from telescopic data or artists' fantasies, but as it really is, a gloomy, rust-red wasteland dotted with cracked stone slabs under a dense, murky sky. There were no traces of the ancient seas once thought to exist, no hint of vegetation or organic life, just a stark portrait of a world that had probably undergone a catastrophic transformation. Venus, once considered by some theorists to be Earth's sister, now looked like a warning. Its sky was filled with carbon dioxide and sulfuric acid, creating a greenhouse effect so extreme that the planet became uninhabitable for any known form of life. The implications of this discovery reverberated through laboratories and academic halls across the United States. Before this, there were competing models of Venus's atmosphere and geology, and some American scientists still hoped to find temperate zones or even microbial life on the planet. Venera 13 shattered these hopes with its harsh data. The surface of Venus was dry, acidic, and baked under relentless heat. Soil analysis revealed a basalt composition similar to volcanic rocks on Earth, suggesting a turbulent geological history with large-scale lava flows. The density and composition of the atmosphere indicated not a planet slowly cooling and stabilizing, but one on a path of increasing thermal imbalance. For American scientists, especially in the fields of planetary science and climatology, this was more than a wake-up call. It was a paradigm shift. The data forced them to rethink the theoretical boundaries of planetary evolution and climate modeling. Venus was no longer just an object of curiosity. It became a mirror in which the possible fate of Earth could be glimpsed. The extreme greenhouse effect on Venus clearly showed that under certain conditions, even a planet potentially suitable for life could turn into a deadly heat trap. This cast a shadow over assumptions about the long-term climate future of Earth and drew alarming comparisons with the rise of CO2 levels in our atmosphere. Technically, the Soviet success highlighted a painful divide. While the US focused on the Moon and Mars, the USSR invested in the development of high-pressure resistant landers capable of surviving the crushing environment of Venus. The accuracy of their entry, descent, and landing systems, as well as the durability of their instruments, surpassed anything the US had attempted to send to Venus. The effect at NASA was immediate. Researchers began to closely study the published Soviet results, searching for every scrap of information. The data changed the American approach to planetary missions. Venus suddenly ceased to be overshadowed by Mars and the outer planets and became a priority for study. The idea that a nearby planet could serve as a terrifying example of uncontrolled climate change inspired both scientific research and public interest. The achievement of Venus 13 also influenced broader philosophical and scientific views on habitability in the universe. The realization that two planets of similar size, mass, and overall composition, Earth and Venus, could evolve so radically differently gave rise to a profound sense of cosmic humility. It debunked the assumption that planets similar to Earth would automatically be similar to it in experience or fate. The sensory perception of the data from Venera 13 was particularly eerie. The sound of the Venusian wind, recorded and transmitted through interference, gave a ghostly, almost mystical glimpse of such an alien and inhospitable place. These recordings, although limited in quality and duration, elicited not only an intellectual but also an emotional response from American scientists. U.S. geologists and planetary scientists were amazed by the basalt landscapes in the images. Fragmented plates and unusual erosion patterns sparked debate about geodynamic processes. Without plate tectonics, as on Earth, how does Venus maintain its geological youth? The implications were serious. Either Venus has a completely different mechanism of heat transfer and geological renewal, or the planet undergoes episodic global surface remodeling processes. Even the limitations of the mission, its short duration and problems with data transmission through the dense atmosphere, only underscored its greatness. American engineers were forced to acknowledge the exceptional reliability of Soviet systems. Every byte of data transmitted by the probe before its inevitable demise was priceless, squeezed out of moments bought with careful engineering and a daring dream. The realization that the USSR had quietly achieved this against the backdrop of Cold War tensions only added to the sense of amazement and involuntary respect. The US scientific community was stunned not only by the data, but also by what it represented. Their Cold War adversary had penetrated one of the most hostile environments in the solar system and returned with revelations that changed planetary science. The Venera program became a benchmark for what could be achieved with perseverance, skill, and a willingness to take risks. It became clear that Venus was no longer just a mysterious light in the night sky. It had character. It had fury. It had stories hidden beneath its scorched crust, and Soviet scientists were the first to hear them. Once the scale of the Soviet data was fully realized, it began to find its way into textbooks, conference reports, and even science fiction. Venus, once imagined as a paradise beneath the clouds, became a stark warning. US scientists hastily revised not only their models of Venus, but also their priorities in interplanetary exploration. Missions to exoplanets gained new momentum, inspired by the harsh lesson that even the most Earth-like worlds can hide hell beneath their clouds. Venus became a symbol of scientific humility, a reminder that external similarities do not guarantee favorable conditions. American atmospheric scientists noted that the efficiency with which Venus retained and amplified its internal and solar heat was alarming. This confirmed models predicting threshold values and positive feedback loops, where small changes in atmospheric chemistry can cause uncontrollable heating. Venus had clearly crossed such a threshold in the past. The data revived interest in comparative planetology. By comparing Venus with Earth and Mars, scientists explored the entire spectrum of Earth-like planet evolution. Venus, far from being a failed Earth, was another Earth that started from the same initial conditions but took a completely different path. The Venus missions, and especially the success of Venus 13, exposed this difference. They forced American scientists to think about the fragility of Earth's equilibrium and how easily it could have been disrupted under different initial conditions.